Hello, and welcome to the final installment of our webinar series for AI builders. We're so glad you could join us for what is sure to be an insightful conversation about taking AI for good solutions to the next level for transformative social impact. My name is Becca Portman, and I'm the Community Success Lead at the Patrick J. McGovern Foundation, a 21st century philanthropy dedicated to advancing AI and data science solutions to shape a more sustainable, equitable, and thriving future for all. Whether you've been following along since the beginning of this webinar series, or if today's discussion is the first time you're joining, we're thrilled to have you here. This series is about diving into each phase of what we term the AI journey, essentially how organizations navigate integrating AI into their work to further their mission, with today's session focused on the last phase of that journey, the impact phase. If you missed those prior installments of the series, don't worry, we've posted the recordings both on our YouTube channel and on PJMF's Learning Hub under each of the corresponding AI journey phases. These include the curiosity phase, where we talked about topics like organizational readiness, gaining stakeholder buy-in, and how to keep responsible AI practices central to your efforts. The exploration phase, where our guest speakers dove into the importance of understanding the problem at hand, sourcing quality data, and seeing what buy options are out there before building a solution. And the adoption phase, where the conversation touched upon the process of building an AI model that works for your organization's needs, the importance of community participation during product development, and more. This final phase, the impact phase, will be focused on how to take an AI solution from pilot to scale, how to continuously adapt it based on learning and evaluation, and how organizations can give back to the wider ecosystem in the form of sharing knowledge and assets with others in the sector. To ground our discussion today in real-world experiences, we've invited 3 of our grant partner organizations who have built and scaled incredibly impactful AI solutions to join us for our panel. We'll first hear a short presentation from each of our guests, followed by a moderated discussion. We should have some time for a couple of audience questions at the end, so we invite you to submit any questions you have for speakers in the chat. Lastly, if you want to share this event with others in your network who may benefit from today's topic, we'll be posting the recording on our Learning Hub Impact page after the event. With that, I'll pass it over to my colleague, Antoinette, to introduce our 3 panelists.
Thanks, Becca. Appreciate it. My name is Antoinette Marie. I'm the Director of Strategic Capital, leading our foundation's grant-making function. I will also be your host for our conversation today, which will be kicking off by introducing our panelists. As Becca mentioned, we do have an audience Q&A session towards the end of the program, and my colleagues will also be present in the chat to help me capture your questions for our Q&A. So feel free to drop those in as they arise. And now for our introductions. Our first presenter will be Rouella Mendonca, who has over 15 years of experience building scalable, innovative digital solutions across biotech and global health, including work at industry leaders like Microsoft. She heads up engineering and AI innovation at Audere, a digital health nonprofit, and leads strategy, technical direction, and cross-functional execution for AI-powered platforms to improve health access and outcomes in low and middle-income countries. Her work spans the design and deployment of responsible, real-world AI systems with deep experience across computer vision, machine learning, large language models, and natural language processing. Rouella has a strong track record of translating advanced AI capabilities into accessible, reliable digital health solutions used in resource-constrained settings. Up next, we'll hear from Nicoll, who leads AI and engineering at the International Rescue Committee, building humanitarian information systems, including AI, to provide information and digital aid to people in crisis. In addition to responding to crises in Afghanistan, Ukraine, and elsewhere with digital tools, Liam focuses on the SignpostAI.org initiative, de-risking AI for scaled humanitarian use cases. Liam and his team have developed responsible agentic AI systems for humanitarian chat and voice communications, predictive flood alert systems, and digital enrollment systems to place people in housing. Liam has scaled responsible technology products for the UN SDG Action and EU Humanitarian Innovation Prize-winning Signpost project to bring humanitarian information to 115+ million people across 30 countries. And finally, we'll conclude presentations with Peter Gault, who is the founder and executive director of Quill.org, a nonprofit that helps millions of low-income students become strong readers, writers, and critical thinkers. Quill uses AI to provide immediate feedback and coaching on students' writing, enabling them to revise their work and quickly improve their skills. To date, Quill has helped 11 million K-12 students in the US become strong readers and writers by providing AI-powered feedback over 2 billion sentences. In 2024, Peter was named a Mozilla Rise 25 Changemaker for developing ethical and trustworthy AI. Quill has been recognized as one of Fast Company's most innovative education companies, MIT Solve Prize, the Gates Foundation Literacy Courseware Challenge, and Google.org's AI for Social Impact Challenge. Peter studied philosophy, political science, and history at Bates College and helped students build critical thinking skills while serving as a debater and mentor for the Brooke Quimby Debate Council. And now I will be handing it over to Rouella for her presentation.
Hello, everyone. I'm Rouella Mendonca, and today I'm going to present what changed when our AI systems moved from pilots into scaled public health systems. So I'll start by talking about who Audere is. I work at Audere, which is a nonprofit co-headquartered in Seattle and Johannesburg, South Africa. We were founded over 8 years ago to develop innovative digital tools to advance health equity. Over the course of 8+ years across 12+ countries, we have scaled our rapid diagnostic AI tools and self-care platforms from pilots to nationally integrated digital health systems. Next slide, please. This is Francois. Francois is a community health worker in Rwanda. While treating patients far and wide, she juggles multiple responsibilities and often faces burnout, while continuing to provide essential health services and manage her own household and livelihood. For community health workers like Francois, the current lack of effective, timely mechanisms for supervisors to support their activities and verify their contributions at scale poses a challenge. Along with this, community health workers do not want another app to use and just want their current workflow enhanced. So support in their daily activities, feedback, and opportunities to provide better patient care are pivotal for these frontline healthcare workers, and this had to be translated to scale. If AI does not actually strengthen health systems, it won't scale. Next. So in a field study conducted with Japaigo in Rwanda with 200 community health workers, our goal was to gauge the value of AI for supportive supervision of a scaled workforce and ensure that there was trusted surveillance data for infectious diseases. From this study, we learned that the AI enabled supervisors to identify 9% of health workers who required support, as they had an interpretation accuracy on rapid diagnostic tests below 85% when compared to the AI. For a supervisor, this information is gold. Now they know exactly where to focus their attention. And having this type of data helped raise trust between community health workers, their supervisors, and the health system, with CHWs feeling more accountable and supported. And now, in relationship with FioNet, this is scaling to 58,000 community health workers nationwide in Rwanda. And all of this is being run completely offline without the need for connectivity, with local data residency, and with an opportunity to expand to other conditions. This fulfills key Rwanda Ministry of Health goals around supportive supervision at scale and real-time surveillance. As we scale in Rwanda, we realized that scaling AI isn't just about model performance. It was about embedding into actual human systems. That includes training humans, understanding local contexts and constraints, and adapting to account for them. Next. When we first started building out our computer vision to read and interpret rapid diagnostic tests, we had to capture a lot of images, and it took multiple months to fine-tune for every test. A key component of value is cost effectiveness, and this process was expensive and time-consuming. With support from the McGovern Foundation and the Gates Foundation, we got a lot more efficient. At scale, we built a foundation model that could generalize across test brands and settings. This allows programs to continue to function when things like stockouts happen or when tests need to be switched out in the field. These are real-world considerations. And the foundation model now can be fine-tuned for a specific test in just 2 weeks to achieve 95 to 99% accuracy. Or you can actually build these models yourselves with a no-code foundation foundry. Next. As we scaled, we realized that no single AI modality was enough. And so our toolkit also expanded to support the care journey. Computer vision ensured diagnostic accuracy, but our self-care toolkit now added on language models to support counseling, predictive models to prioritize risk. And finally, the real shift at scale was building our hybrid monitoring and evaluation service, which ensures that AI is rigorously evaluated before launch and during use in the field. This helps us ensure safe, ethical AI outputs continuously. Each of these services are co-designed, developed, and monitored with local communities across Africa and India. Next. When we started, impact meant model performance, whether the computer vision model interpreted the test correctly, whether the language model generated an accurate response, whether the predictive model stratified risk correctly. But as these systems moved into scaled health workflows, impact became about something else. We began to look at, were frontline workers actually better supported? Did clients receive timely tailored guidance? Were higher risk clients prioritized sooner? Could we detect model drift or harm signals in real time? And lastly, does the value justify the cost and risk? The biggest shift for us was moving from evaluating AI components to evaluating AI as part of a service delivery ecosystem. We also had to pivot a lot along the way, from cloud first to offline first, from fine-tuned models to foundation models, from just computer vision to a broader AI toolkit, and from static evaluation to continuous monitoring. Next. No AI system scales alone. National scale requires ministries, implementing partners, digital health platforms, and regulatory alignment. And it is these strong partnerships that are the real backbone of scale. Next. So that was my presentation. And if you are interested in learning more, please reach out. Thank you for your time, and I look forward to connecting.
Thanks so much, Rouella. And next we'll hear from Liam.
Hey everyone, I am Liam Nicoll. I'm the product lead for AI and innovation at the International Rescue Committee, and I'm going to talk to you today about scaling agentic safety in crises. The International Rescue Committee is one of the world's largest aid organizations, founded in part by Albert Einstein, and now supports people in around 40 countries across the globe to receive humanitarian aid. When crises happen, though, currently, the needs vastly outpace the size of the responses. So an anecdote from 2023, there was acute famine in Afghanistan, and a single post that we put onto Facebook triggered 48,000 incoming questions to social workers. We only had 6 social workers in that country, and essentially we could not respond fast enough. Those crises do not scale linearly. There's spikes instantly, globally, without warning. They can happen wherever, whenever. And in this kind of new world disorder that we're all living through in the current moment, that same program now only has 2 staff. So this is a global ratio of people in need to staff 1 to 1 million. So we started in this work in 2023 to try and answer this problem of, can we actually, in the same instance, be able to respond to all of those 48,000 messages within a timely manner with accurate information. So we tested basically the first generation of these tools, which was a foundation model, LLM, with retrieval augmented generation. And we found that when we set it against our quality score, which was a human judged score that was then trained to an AI model, we found that We got some minor efficiency gains, but our quality score was only 70%, which was not sufficient or comparable to the quality of human social work. So the LLMs in particular lacked humility, which which made it so that we could not trust them to efficiently conduct social work digitally. So as a result of this, we spent time and energy over the last year with the McGovern Foundation to build for agentic safety and find ways that we can prevent this lack of humility. So what did we do? We ran a year-long experiment to prove that it was possible to have direct to client AI communications, so that we would be able to begin to answer the question of how to reach more people at scale. So the first thing we did was we benchmarked, we set that standard for quality evaluation, and the human quality rate on a test simulation of previous historical questions and new and test questions was 87.5%. We selected an agent as a judge, and we began to test our approach against that judge. From that, we added guardrails, so a number of different safety methods. And ultimately, that led to a simulation that we conducted just last month, where we found that the AI was able to handle autonomously a percentage of those questions. Now, in order to kind of get through that methodology, the most important point of failure was on guardrails. We are dealing with very difficult requests. Sometimes people are asking about social services. Sometimes people are going through mental health crises, are in situations of domestic violence, are in urgent need of malnutrition care, etc. So we needed a way to enable us to be able to have direct to client communications, but also ensure that we are kind of offsetting risk and the most complicated queries where no humans should be subjected to a chatbot when they're in the worst crisis of their life, be able to kind of escalate to the right humans at the right time in the process. So we made a number of different guardrails, the ultimate guardrail, which determined, does this escalate to a human? Did this person ask to speak to a human? Was this high risk? What was the risk level? Like how severe was the risk? What was the type of risk and kind of how was it classified? And we classified it against an industry standard, the MIT AI harm taxonomy, which we adapted for humanitarian crises. And then we had a judge, which basically judged whether it was good or not as a response. So you can kind of see this is what these types of agentic systems look like in actuality. Hey, I'm going to the Darien Gap to Panama. I'm afraid I will be unsafe. This is the border between Panama and Colombia. It's a migration route. How should I navigate it? And you'll see right here the escalations after the LLM responds basically determine, should the AI answer or should a human answer? And in this case, it's saying a human should answer because of dangerous journeys and crossings. We reached a breakthrough. So in simulations, we found that we could go from 3,780 clients with our staffing threshold of our pilot country in Mexico to 2.2 million with the same degree of resources and cost. That is a reduction from $15 per client to 2 cents, 2 to 3 cents. In this, we found that the quality rate was within the margin of error of a human kind of social worker's communications for the types of questions that were not high risk. So high risk questions, the humans vastly outperformed LLMs, as they should. And for any question that didn't reach, our top severity of risk, the quality rate between the two was standard. So basically, we learned that this is a system that is actually deployable into production, into humanitarian crises. So what does this mean for the future of humanitarian aid? It starts to paint the picture for what a humanitarian 2.0 model might look like, where there's cooperative AI, there's acute knowledge warning systems, and warning systems that have the ability to understand the context. So floods, droughts, conflict, market prices, where services are, in addition to knowledge about what are the laws that changed today, or what are the most common questions people are asking, and scale and ability to deploy this model at scale. So we're excited kind of in the next year, 2-3 years, by 2030, we're hoping to build this humanitarian 2.0 model and ship it to every one of those 40 countries that the IRC operates in. Appreciate it, everyone.
Awesome. Thanks, Liam. And finally, we'll conclude presentations with Peter.
Great. Hey, everyone. Really thrilled to present today. Quill deeply believes that writing is a superpower, that when you can advocate for yourself, when you can fight for your own ideas, that unlocks so much autonomy. And that for young people, becoming a strong writer takes so much time, it takes so much practice. And so we started using AI back in 2018 as a tool in classrooms to give feedback and coaching to kids to help them write and practice and get at-bats. We've now helped more than 12 million students, and these students have written and received feedback on more than 3 billion sentences. So we have one of the largest data sets of writing ever collected. This really speaks to the very scalable nature of AI, that if you build something that works really well, it can have this massive impact. But for our work to be successful, our feedback and coaching needs to mirror how a teacher would provide feedback and coaching to students. And AI out of the box doesn't always do a great job. It's a difficult problem where AI wants to tell you the answer, it wants to solve your request. And so applying it to education and applying it well means a lot of custom training, a lot of data sets, and a lot of evals towards understanding how well are we performing, say, relative to a senior educator. And so for today, I have something really special. I'm sharing our eval infrastructure for the very first time. I've never shared this publicly on a webinar before, so just as an FYI, I've shared it privately, but this is our very first ever public presentation of our internal infrastructure. So I'm going to do a very quick live demo. I'm going to show you first how Quill works, so you have context for the problem we're solving, and then I'll jump right into the eval infrastructure so that you can see it. And then from there, we'll jump right into the Q&A so that you all can ask your questions about it. Before I begin, though, I want to share just one quick tweet from Greg Brockman. Evals are surprisingly often all you need. You'll hear this a lot now in the world of AI, that evals are so important. Getting them right is so difficult. And I'm hoping today to help share what we've learned in this space. So very briefly, I'm going to just show you what Quill actually looks like. Students are reading and writing in Quill. In this case, this is part of a new unit backed by the McGovern Foundation, teaching kids about AI and building their knowledge. In this case, we're teaching kids about LLMs and how they work. Students are given this prompt. CD needs a large amount of data to train their large language models because ... Kids will say things like, because they want to speak with whales. You know, this makes sense, but when you press get feedback, we say clear your response and try again. Instead of talking about the mission, explain why they need lots of data. And so there's a level of precision here where the students have to build a strong claim and use precise evidence. And then when a teacher is scoring a student, this is what they're looking for. And so our AI needs to do the same thing. In this case here, it's about going back to the article and explaining why they need a large amount of data. And that can be because, you know, they want to avoid misunderstandings, right? So you can put that in here, for example. This is a true and correct response, and many LLMs will flag this as correct. But in our case, we say, now build on your response. What could lead to these misunderstandings? We really want you to deeply understand this content. And in this case here, right, it's all about how a small amount of data you can have misunderstandings. And that's why you need a large amount to train your LLM. Revise again, because a small amount of data could lead to misunderstandings. You press get feedback, and now you've had this great, nice work, use the information to explain why they need a large amount of data. And so this might not seem like a big deal, but when teachers are really coaching their students, there's a level of precision and care that goes into their work. And then when we're asking AI to mimic teachers and to provide that same feedback and coaching to students, we need really robust systems to look at our writing in a very precise way to lead to those revisions and those improvements that go from this is an okay idea to this is a precise and evidence-based response. So with all that context, let me just right into our eval infrastructure. What you're looking at here is our trial runner. What we do is we build golden data sets where we look at student responses. We have a team of 10 former teachers, and they spend all of their time grading writing. Quill grades something like 100,000 sentences per year across all of our team members. It's an incredible amount of grading, and that powers all these data sets. And in this case here, it's a data set comparing how students respond to this prompt. From there, what we do is we take a temperature check of how does an LLM perform on this task. And so what you're seeing right here on the right-hand side, I know this is really small, I'll try to zoom in here, but you'll see the 65% number. The 65% is the accuracy of the AI with no custom trainings or out-of-the-box model's performance when it comes to understanding a exemplary response versus a non-exemplary response. And so that's all to say that when it comes to AI in education, 2 out of 3 times, the base model provides accurate feedback to students. However, you can imagine in education how it's so important to be precise, to be reliable. And in this case here, what we do is that we add a lot of training examples into the prompt. You can see here, for example, we added about 89 examples of responses that we hand scored into the prompt. And then this shoots up the accuracy from 65 to 97% accurate. That's, of course, the challenge with AI. AI is a prediction, it's a generative technology. And so it's never going to be 100% reliable in every case. But the more training, the more data that you put in, the more eval that you can do, you can really make a world of difference. And we saw that in the other 2 presentations as well, how we've all jumped the gap from like this kind of works to this really works. So I encourage you all as you're building your work to think about how will you evaluate your AI and what infrastructure do you need? And then there's a lot of work that goes into building this. Thankfully, vibe coding makes this easier, but a lot of our time is spent not on just creating the AI itself, but creating the infrastructure and the evaluation. So in this case here, for example, I'll zoom out again. You can see this is our hand-graded data set to the left. And then these are the performance of the 2 models side by side, or the 2 different prompts. And you can see here in this case how the model gets it wrong on the right-hand side, provides much better feedback on the left. And that really reflects the impact of this custom training that we embed into the models. And so we just think that AI is an incredibly powerful technology. And when you're serving a particular community or audience, you really need to do right by them. And you can do right by them, but that means building data sets and evaluating your work and understanding what exactly do they need, and then training these systems towards doing that work really well. And then in turn, you can reach this massive scale, helping millions of students, providing feedback on billions of sentences. I'll leave you with one last stat here. We just did a quick data analysis where we saw that students write about 5 billion words on Quill each school year. For comparison, there were about 1.5 billion words written on all of Substack. And so we're seeing on Quill about triple the amount of writing as all the writing on Substack. And to me, it really speaks to just how powerful these tools can be when you get them right. Nonprofits can just massively scale, but you first have to ensure that you really have something that works well. And the McGovern Foundation has just been a wonderful partner for investing in organizations that are doing this work and enabling them to jump this gap between this work some of the time, and this is a highly reliable tool for your clients. So I'll pause here. I'm excited to jump into the Q&A and happy to follow up over LinkedIn with folks who have more questions.
Great. Thanks so much, Peter. We're going to move into our panel. I'm going to let everybody come on stage here. Great. So to kick us off, I have a question for each of you, and we can go around the horn and maybe start with Rouella. As we all know, scaling an AI solution to meet the needs of different communities is a challenging endeavor, and it requires engagement with a broad group of stakeholders. And I know that for each of you, defining that broad group is different per use case. Give us some insight into how you went about that process. What practices did you follow to ensure that you maintain mission and product integrity while also meeting the unique needs of different user communities? And Rouella, we could start with you.
100%. So Antoinette, like one of the big things for us is anytime we actually went forward on a program, co-design was a huge deal, and it continues to be that. So like starting on whether it is the computer vision work that is scaling in Rwanda or in Burundi or some of these other places, or the self-care work, we for us, it was always and continues to be a priority to work with the local communities. So generally, if we start a new program, we'll spend about a week with key stakeholders. This includes like users who are actually using the tools, ministries of health, the local implementation partners who are there. That way, like, we're thinking about this right from scratch. And then we continue to involve these communities as we continue to scale and grow. We keep an eye on things like bias that may actually exist based on what we have done over there. We measure outcomes along the way. And we have communities involved with us, even in red teaming, testing, development throughout the process. This ensures that what we're building is not just like we're going to create a tool and put it out there and hope it works. We are actually taking the input of communities so they are more motivated. The value is actually being delivered to them that they actually need. And we're working within like the constraints that actually exist in the real world and building for those constraints.
Yeah, that makes a lot of sense. And kind of building off of the notion that Peter just left us with about benchmarks is everything. Can you tell us a little bit more about the red teaming piece?
Yeah, no, absolutely. For us, metrics have been like super important in general. And I kind of brushed over this a little bit, but similar to Liam and Peter, for us, it's been huge investing in an evaluation and monitoring framework and making sure that we have it. But at scale, I think the leap that we actually took was we built a hybrid framework, which means we have an automated framework that actually works to evaluate things on a continuous basis and at regular intervals, comparing different LLMs or looking at a computer vision. But we have local communities that are also involved in actually taking a sampling of that data and ensuring that we are getting their input. We also have local communities who will try adversarial conditions with some of our tools, see how it actually behaves, help us build those pathways to actually address those conditions. So it's a wide range of different ways in which we're constantly evaluating the tools, and community is involved, again, at each of those levels.
Really good. And Liam, curious to hear your thoughts here.
Yeah, so as it relates to benchmarks and red teaming is an inherently interdisciplinary function. I think we think of it, and for those who don't know, it's kind of attacking your system just to make sure that your system is meeting, standards. Depending on your point of view, you might attack it very, very differently. We learned that the more we're able to get all the different stakeholders in the room, meaning the people who have the best sense about the content or the data's like accuracy or provenance, the engineers who know the system, the subject matter experts who might really know a lot about malnutrition, the programmatic leadership who might know what types of outcomes they want to get as a result of the actual tool, and based off of clients, like individual clients who might actually interact or users. Red teaming can take different forms dependent on how we convene people. We've found that by short, intensive sprints that happen on periodic bases, we're able to like get a really clear sense of how well systems are working. And yes, that involves metrics. So we want to both understand that qualitative information from the red teaming, but also to have benchmarks of metric systems based off of those expert teams or those interdisciplinary teams' perceptions of what is good or bad. So it usually starts with you ask that group of people, that steering committee, like what is good, what is bad, and eventually you can work back to having AIs being able to support those people to also help identify what is good and what is bad. When you're at high stakes, and these are scenarios in a crisis, like there is no margin for error here, or there's very little margin for error. And part of that margin for error is baked into the technology. Like the technology is not 100% reliable. So basically, at the end of the day, there is a leap of faith, and that leap of faith is determined by the body of the metrics you've determined against your baseline score. Like where were you before and where am I after, based off of these different tests and simulations. And in some cases we say, we spike the ball and we say, no, we're not going to deploy this. It didn't exceed baselines or standards. And in other cases, we'll launch it provisionally with like a short-term leash or like an A/B test in order to make sure that it's meeting standards. So it's a contextual thing.
That makes a lot of sense. And later on in the conversation, I'm going to ask you each about kind of a major moment of pivot that you experienced in your work. And I can imagine that some of this red teaming sprints is one of those moments that may have led to a pivot. But before that, I want to invite Peter to share some thoughts on this question as well.
Well, to build off what Liam was saying, before going from sort of 0 to 100, you really want to sort of work. There's always this like working with partners, but working with partners in AI is not just a nice to have, it becomes absolutely critical. So in Quill's case, that means we work with 600 teachers in an advisory council across the country. And anytime we're building anything new and before we're putting it in front of, the millions of students and teachers using Quill, every single thing goes to the advisory council and we're having them use it. We're having them give us the feedback, but it gives us a chance to have a controlled test of how is this going? And then all that test results feed back into improvements that we make to the system. And so testing and improving isn't just a nice to have. It's not just sort of a one-time thing. It's something that you have to build infrastructure for. You have to figure out how to recruit these people. You have to give them gift cards and pay for their time. And sort of having that infrastructure takes away some of the risk here of going from 0 to 100 and then the potential harm that might come when your thing doesn't work as well. And so setting up those systems really shifts things in a big way and becomes a sort of a real strength for doing this work ethically.
Wow, that's really impressive. I wish we had more time because I'd love to dig in more on the advisory council and how you got that set up, but maybe we could reserve that for a question at the end. Rouella, I have a question prepared for you. For the audience, Audere has advanced 2 major streams of AI work over the past 6 years, including a computer vision model that you've scaled across several countries, and then an AI companion using LLMs for direct patient engagement. How did your metrics of success differ for both of those efforts? And can you describe the evolution of how you approached the M&E process as you scaled the computer vision model versus your LLM, and whether different metrics become more or less important over time?
Great question, Antoinette. So in a single line, like the biggest difference is that when you're looking at computer vision type AI models, you're measuring objective correctness, and you're doing this in a fairly deterministic way, while the AI companion uses large language models to influence behavior and perception, and each interaction and each response that you get could vary. So early on for both systems, like we focused heavily on model performance, and the difference in the metrics was for computer vision, that meant looking at sensitivity, specificity, weighted F1 scores. But when we looked at the AI companion large language models, it meant now looking at locally contextual correctness, completeness, hallucination rate, safety flags, and how it reacts. The biggest pivot point in when we actually began scaling this work was once deployed in the field. While those metrics are still critical to measure on an ongoing continuous basis in alignment with what Liam and Peter were just talking about, and this continues to be a huge investment for us, but they aren't really enough alone, because we had to now start measuring outcome and system level metrics in addition to these metrics. So for our computer vision deployments, these were things like how many community health workers were flagged for supportive supervision, or what are the false positive or false negative rates and downstream implications, or the equity when you actually look at real world conditions. And for the AI companion, it was things like, is the guidance that's being provided behaviorally appropriate? Is it culturally appropriate? Is escalation to human care happening when it needs to happen? Are users making safer decisions? Is performance consistent when you include new languages and new contexts and new key populations into the mix? So correctness wasn't enough, and we had to now start measuring alignment with human care pathways and health systems in general. And the biggest other evolution was moving from static evaluation, which means we do just like an evaluation at points in time, to continuous monitoring. And a point in time evaluation we found out was insufficient because models are evolving, the actual environments they're working in are constantly changing, and usage patterns are shifting consistently. This could be because of global health changes, it could be because of like changes on the ground. So we had to build systems to monitor drift, detect harm signals, and be able to track equity in real time. And this allowed us to iterate responsibly rather than reactively when something went horribly wrong. So our impact had to mature from just model level performance to thinking about almost system level accountability at a higher level.
Can you give us a sense of just how difficult that transition was, or perhaps even how easy it was? What did it entail to go to continuous monitoring? So I imagine there's a good story there.
Yes, no, it entailed, so the point in time evaluation, like a lot of folks are doing it, it is one of those things where there are benchmarking things. But the way we had to approach it, even at that time, was thinking through what metrics actually matter for these communities, right? And like, I'll split it into like outcome metrics. What change are we actually trying to make, and how do we actually capture that data? And then when we think about safety monitoring, it's like, hey, what does accuracy or completeness or correctness actually mean in that particular context, and build our metrics accordingly. The transition was like, again, I'll go back to it, was co-designing with clinicians, with people on the ground to ensure we understood. And this also included what did ministries actually care about? Where did they care about actually making a difference? And then right from the beginning, Antoinette, like we learned about it, we missed some metrics. It was about continuing to add like logging and tracking. I'll give a quick example of this. Like we found a few people, even though they had the right referral pathways, they weren't actually connecting to care. So we began adding logging, collecting barriers to care. And then we started learning more about like, why are people actually not uptaking care? And there may be structural barriers or social determinants of health that are unrelated. And that informs future product development that continues to grow it. But it is, what I will say is we haven't completely figured out everything yet. It's an ongoing process, and we continue to learn. And priorities, as they actually change for governments and they change for implementing partners, knowing like what is actually happening in the field allows us to adapt quickly. So it's a lot of data capture, a lot of data analysis, and a lot of how do you actually gain insights from the data versus just capturing it.
Thanks, Rouella. This one's for Peter. During one of our earlier conversations, you mentioned that Quill has kind of honed in on its approach to evaluating impact over the last 7 years. And we had the privilege of seeing the first public announcement into that, particularly as more and more students have benefited from the use of your tool. How did you adapt the tool to different student needs, and what kind of data sets were most effective in ensuring that the tool served as a complementary aid for teachers as opposed to a distraction or a replacement for direct instruction?
So what we see in the classroom today is there's not a lot of writing. That writing takes a lot of time. You have to get a whole pile of papers, which teachers then have to grade by hand. And so kids don't get a lot of at-bats. And so as we were thinking about how AI could support this, we recognize that grading writing isn't just, it's a little harder than math, right? With math, you've got to write in the wrong answer, but with writing, it's contextual to what are your expectations for a good sentence? And writing styles vary. You have different types of writers that have different approaches between like these long sentences and short sentences. And so we had to come in with our own philosophy, and it had to be built specifically for students in underserved schools. As a nonprofit, we're really thinking about those students coming from environments where there aren't as many resources towards doing writing practice. And so what did the writing look like for these students? What did it look like for the 4th grade students versus the 8th grade students versus the 12th grade students? And so you have to sort of very patiently work with these schools and collect that data and understand what it looks like, and then bring in subject matter experts. And that's the hardest part of AI development. It's not the technologists, it's really those experts who understand this is the dividing line between a exemplary response and a response that could be improved, for example. And that really varies. There's not one or right or wrong answer to that question. And so it was through a lot of that testing and iteration that we're able to sort of build those data sets and find that sweet spot. In turn, we then do research studies. And so we did a really big study last year looking at growth among 100,000 students, and we saw great results. We saw a 1.6x rate of growth for the students who are actively using Quill, but in particular, we saw the greatest growth for the students coming from Title I schools, the low-income schools using Quill. And so all that effort up front, sometimes takes years to build these things, and then being able to do a proper research study can be a great way of then evaluating your work. But you have to design with a particular audience in mind from the get-go to then get those results, which might happen in the future.
Yeah, I appreciate kind of sharing a little bit more about your kind of cycle of testing and feedback loops there. My next question is for Liam. I think we all understand the value of technical interoperability somewhat intuitively, that being able to share or transfer information between systems at a baseline is an important thing. During an earlier conversation in preparation for this discussion, you suggested that a single solution to an important problem can unlock many useful product pathways across differing use cases. And I think your position is at the center of this idea. And I'd love for you to tell us a little bit more about that. What's the unique product development mindset that has enabled IRC to get to efficient scale across multiple use cases?
Yeah, it's a really good question. I think the new term, like context engineering, of the last couple of months kind of like most efficiently captures this. Is humanitarianism doesn't happen in a vacuum. It happens in the most difficult political scenarios with the most factors moving around. It could be driven by the global financial market. It could be triggered by conflict, by climate, the people having interpersonal conflicts. It could be top-down political. This is just to say that the context defines how well any of these systems will work. And if these systems do not have an understanding of the context at a scale that really no human could kind of observe, it's going to not meet the moment. So for us, content and the different formats that it can take is highly variable. And we've had to basically engineer systems that can intake different types of information based off of what's happening in that crisis on a moment's notice. So I'll give 2 examples, and I'm gonna quickly show this because otherwise it's kind of hard to understand. I'm just going to show you, like, for Sudan, for example, there's geospatial context that might be the answer to certain questions, like where's the front line of the crisis. I might be able to actually see it visually, but not everyone would have access to this. If I'm a client, I might not know how to interpret a map, but I can use this geospatial information to perpetuate and provide an answer. In a hurricane context, the government might provide a single PDF on their website if you're in the context of this past hurricane in Jamaica. But who knows to look for that URL? Who knows where those services are when they're named? How do I triage them back to a geospatial location? And then if a person asks in plain text, hey, I'm in Kingston in the Northeast neighborhood, which shelters have space, that information can only be determined by triaging multiple sources of information. So the way that we see, like, kind of engineering and interconnectivity is that in the information age, like, we need to know the most up-to-date information, and it will come in whatever format it comes in. It could be a voice message from David Miliband. It could be a message from a client that tells us what's happening. It could be satellite imagery, or it could be that report that drops from the Jamaican government.
Yeah, that's a really, really good point about the data coming from disparate sources. But the novelty or the use of that data actually comes from unifying that and giving a direct answer. We're getting to the end of our time together, and I'm going to use the opportunity to prompt the audience to drop in any questions that they may have for our panelists into the chat. And while that goes live, I am able to get to that last question that I've been wanting to ask, which when it comes to building and deploying an AI solution for different contexts, it's important to have the organizational and technical maturity to understand when the tool is or is not achieving its goal, or potentially even causing unintended secondary impacts. So for each of you, and we can start with Rouella at the top, what were the key realizations you had along your AI journey that led to a decision to pivot or change your approach? And if you could also share, like, how'd you communicate that change to your team, to your funders, to your user community? What did that communication strategy look like?
Awesome. So I mentioned like how we spent a lot of time co-designing and understanding like what metrics actually mattered along the way. And I mentioned a few learnings in my presentation, but I'll give one like specific example over here about some behavioral learnings that actually made us pivot some of our approaches. So when we introduced self-care tools, like we expected this to completely take the load off of clinicians, but there's an option in there which allows you to connect with a real human if you want to. So when we first introduced it, what we noticed was clinician workload, instead of going down, actually initially increased, because users were like, oh, free nurse consult. I'm just going to go in there and click on that button. So we actually had to completely rejigger the way we built out the user experience over there after looking at some of these metrics, and encouraged people more, like using these UI tweaks, to chat with the AI companion first. And over time, we gradually got to see that clinician burden actually started going down because they got a lot of the basic answers that they wanted directly from the AI companion. The other key pivot was we also discovered a lot of secondary impacts of these tools. Like we planned for, okay, these are the places we actually want to have impacts in, but people began sharing, I mentioned social determinants of health, contextual barriers that weren't really captured in traditional workflows, which also helped clinicians in their prioritization and how they actually interacted with these clients then. How we framed this, and that was the last part of your question, was whenever we had to pivot, we actually framed it as like the maturity of it. And because it was maturity versus like we failed at something, because we had the monitoring systems in place, we were collecting a lot of these outcomes. We create like very elaborate dashboards sharing the insights. We could then show data on why a change was necessary and iterate very transparently with partners and funders by telling them if we made a decision to pivot or change, what was the reason for actually doing that, and explaining that. And that was pretty critical.
Thanks for that. Who wants to go next?
I have a kind of wild story here that folks on this call might appreciate, but not a lot of people do. So we were using traditional AI before generative AI, and started testing. GPT-3, 3.5 comes out. We immediately start testing it. It's not nearly as good as our own AI, right? We have these very high benchmarks for our own fine-tuned models. We spent years and years fine-tuning, love fine-tuning, but found that generative AI was too unreliable, too unpredictable. Initially, we dismissed it. We didn't really recognize back in 2022 where we'd be today, and I think none of us did. And then we keep testing. Every 2 weeks, we're testing the newest models. And you have GPT-4 come out, and you have 4.0 and these new models. And they're starting to creep up and get better and better, but they're still too unpredictable. They're still too unreliable, and they're too expensive. That if we were to use GPT-4, it would have cost something like $10 million in API calls to do all the work that we were doing with our models. We then faced this really difficult moment where the fine-tuning service that we were using was shutting down. That it was sort of like, okay, fine-tuning is the older approach now. Move to generative AI, and we're like, oh, this is bad. The generative AI isn't as good as our benchmarks are. So do we just, what do we do now? And so we kept testing the models. We started jumping to Gemini Flash, for example. Flash 1 wasn't quite working, 1.5. And just when Gemini Flash 2 came out was like a couple of months before the shutdown of our old service. And we finally saw in that model the results that we needed on our benchmarks to ensure that we were able to create a reliable service. And so we had this quick scramble moment of moving everything over from the traditional models to these new approach. And it really, we knew that the models would eventually get there, but just the sort of timing between this one thing going away and this new thing hitting where it needed to be. And so you sort of have these moments when you're doing this work of like your work being so conditional on the infrastructure and the technology, and you just need to be pretty scrappy, to be honest. But it's part of the game here for sure. But appreciate how for this group, folks might understand and probably have their own stories as well here of all the challenges that go on behind the scenes.
Yeah, I'm going to ask Liam to share his story next, but I can imagine what that team pep talk was on Slack or Teams or whatever medium is when you had to make that scramble happen. Liam, wrap us up here.
Yeah, for me, I think I think we assume people will use our systems for how we assume they'll use them. So, and especially like in the United States, it's pretty obvious to most people that ChatGPT exists, right? In a lot of other places, that's not the case. And so what we've found is that even though we red team to prevent certain types of interactions, people's like first nature to interact with systems. We have an education like assisted learning for teachers who are on the move, who are in displaced areas in Northeast Nigeria. And one of the top topics that came back was around mental health and behavioral assistance, not for the teachers, but for not for the students, but for the teachers themselves. So a lot of those questions looked similar to the ones that you would expect to come from ChatGPT's disclosure of kind of one-to-one messages. So essentially what we learned from that is most of the world has not been exposed to artificial intelligence, at least in face value where they could interpret it. In a lot of those contexts, it's never spoken their language. And now it's starting to be able to speak more and more and more languages. And in that, we should expect that no matter what we're building for, people are going to use it for the purposes of getting access to the tools. So that type of openness is a design question. How open versus how closed? What's the differentiation between what you provide and what ChatGPT provides? And in the case of Nigeria, we had to basically adapt to, actually open up the tool more so we could provide more assistance for the teachers themselves rather than close off and say, no, this is not what we do.
Yeah, that makes a lot of sense. Well, Rouella, Peter, Liam, thank you so much for spending the time and sharing your insights with us. And thanks for everyone in the audience who joined us today.
Thank you.